Hi, today we are going to learn about using the Pythagorean theorem. Let's look at a problem. Solve. 3 and 9 are the lengths of the legs of a right triangle. What is the length of the hypotenuse? Talking about the Pythagorean theorem is a theorem for right-angled triangles. It says if triangle ABC is a right angled triangle, suppose right angled at B, then AC is the longest side, which is the hypotenuse. So the Pythagorean theorem says that the square of the hypotenuse is equal to the sum of the square of the other two sides. In other words, for triangle ABC, we can say AC square is equal to AB square plus BC square. So here now 3 and 9 are the lengths of the legs of a triangle, right triangle. So we can, let's say AB is 3 and BC is 9. We need to find the length of the hypotenuse, that is length of AC. So my AC square is AB square, that's 3 square, plus BC square, that's 9 square, which is equal to 3 square is 9 plus 9 square is 81. 9 plus 81 is 90. So AC is square root of 90. We can factor 90. I can write 90 as 3 times 30 and 30 as 3 times 10. So this is square root 3 times 10, and 3 can be taken out of the square root. So I can say AC is 3 times square root 10 units. So C3 square root 10 is the answer. Next problem. Solve. 10 and 12 are two sides of a right triangle. What are the two possibilities for the third side? Let me draw two right triangles here. Let's say one is ABC, right angled at B, and one is DEF, right angled at E. Now 10 and 12 are any two sides of the right triangle. So let me take, in the first case I am taking 10 as AB and 12 as BC. And in the second case I am taking 10 as DE and 12 as DF. So using the Pythagorean theorem, in the first triangle, this is the first triangle and this is the second triangle. In the first triangle we will find AC, the hypotenuse, and in the second triangle we will find EF, that is the leg of the triangle. So let's apply the Pythagorean theorem in the first triangle, triangle ABC. I'll say AC square is equal to AB square plus BC square, which will be equal to 10 square plus 12 square, which is 100 plus 144, or we can say AC square is 244. AC is square root 244. AC is equal to 244 can be factored as 2 times 61. So 2 can be taken out of the square root. So we can say AC is 2 times square root 61 units. So one possibility is that the length can be 2 times square root 61. Now let's check for the second one. Triangle DEF. We will have DF square is equal to DE square plus EF square. DF square, DF is 12 square, DE is 10 square plus EF square. 144 is equal to 100 plus EF square. Subtracting 100 both sides. 44 is equal to EF square, or we can also say EF is equal to square root 44. 44 can be written as 2 times 11. So EF is equal to 2 times square root 11 units. So we have two possibilities here. One is 2 times square root 61 and one is 2 times square root 11, which is the answer in the D part. Next problem. Solve. Do 18, 15 and 16 form a Pythagorean triple? Now the Pythagorean triple is formed whenever the longest side, the square of the longest side, is equal to the sum of the square of other two sides. So we need to find, does 18 square equals 15 square plus 16 square or not? So let's say 18 square is 324. So let us find 15 square plus 16 square. 15 square is 225 plus 16 square is 256. 225 plus 256. 225 plus 256 is equal to 481. So this implies that 18 square is not equal to 15 square plus 16 square. So we'll say no, 18, 15 and 16 does not form a Pythagorean triple because let me say this is my side C, 18, this is my side A and this is my side B. So I'll say no because C square is not equal to A square plus B square. So we can say A part is our answer. I hope you can practice more problems on using the Pythagorean theorem now. Thank you for watching. Have a great day. Bye bye.